In this video, I'll try to explain why Jupiter and Saturn have a conjunction, as viewed from Earth, about every 20 years. So we're going to use some diagrams and a few calculations, but you should be able to follow all of the information. If you've not watched my other two videos, I'd highly recommend you watch those first. You can subscribe to my YouTube channel and view my playlist, astronomy images and general interest. And then in that playlist, the videos start with the title Jupiter-Saturn 2020 conjunction. But the first of those videos explains what conjunctions are and describes the event happening December 21st, 2020. I'm recording this in the middle of November 2020. You could apply these ideas to other conjunctions as well. It happened in the future years. In the video number 2, I present photographs and measurements off of those photographs for the angular separation of Jupiter and Saturn. Right now, of course, since this is November, those photographs run from September through November. I'll be posting another video that takes the photographs all the way to the conjunction. So we have the case here, a photograph from August 11th, actually. I didn't make measurements on this one, but just to give you an illustration of what's happening here, this was early evening on August 11th from our home in southwest Omaha. And it wasn't totally dark, but dark enough I could record the images here. So Jupiter and Saturn. Faint dots over here, you might be able to pull out the teapot asterism in Sagittarius. So the planets are to the east, to the left of Sagittarius in August when this photo is taken. The situation is that Jupiter moves faster on the sky than Saturn. So Jupiter is catching up with Saturn in its orbit and will eventually in December be very close to Saturn, an unusually close passage of Jupiter by Saturn. The website here you're welcome to go to. It's a JavaScript ORI presentation. You can put in your own dates. But I laid a line on here after I snipped this image from this website. But the line starts at Earth and extends out to Jupiter and Saturn on December 21st. These objects on the sky will only be 0.1 degrees apart. They'll still be very, very distant in space. At a conjunction, it's not anything like a collision. They're only apparently close to each other on space. There is a good discussion of this conjunction in Wikipedia. Great_conjunction is the title of the article. It's called great because the two planets are the gas giant planets of the solar system, Jupiter and Saturn. They will be 0.1 degrees away from each other on December 21st. And this is the closest these planets have been since 1623. I think I picked that off of this website as well. There is a future conjunction that's also very close in 2080, but we're more interested in the 2020 event. Here's a list of some of the dates. There are more dates into the past at that Wikipedia page. So we have there was a conjunction 30 July 1981, and then I calculated how much time elapsed till the next conjunction after that, which was in 2000. This is this year's conjunction, 21 December 2020. There'll be a conjunction in 2040, 2060, 2080, 2100, etc. So I've put in years, months, and day into this timeanddate.com website calculator, and it produced the number of days in between the conjunction. But you can see that it's a little bit less than 20 years, sometimes considerably less than 20 years, and sometimes it's over 20 years, but from one conjunction to the next. Why does that occur? Why isn't it exactly 20? Why is there the variation? Let's answer those questions. First, model of the solar system here with Mercury, Venus, Earth, and Mars, asteroid belt, then the orbits of Jupiter, Saturn, Uranus, and Neptune. The planets close to the sun have the greatest speed. They have the shortest time for their orbit. They're moving at the greatest angular speed across the sky. And Jupiter moves at a greater angular speed than Saturn. So here, Jupiter is going to be moving along here, and eventually it'll catch up with Saturn, perhaps over in this part of the diagram that would occur. Their orbit periods, Earth, of course, is 1 year to go around the Sun. Jupiter, 11.86 years for one orbit, and Saturn, 29.46 years. This becomes important in calculating how much time elapses until Jupiter would be aligned in one date, and the amount of time that elapses until Jupiter comes around and again there's an alignment of the two planets. It won't be in the same spot, but how much time elapses. I'll have some diagrams that explain that. I am going to assume the planets are on circular orbits. This is an approximation. It's not exactly true. The planets are on elliptical orbits, but they're not far away from circular shape. So for this rough calculation, I'm going to assume that they're circular orbits. I will determine the length of time between two conjunction, or two alignments, I really should say. I'm going to take an observer on the Sun, viewing the situation. From the starting situation, Jupiter and Saturn are in the same spot in the sky. And then the next time, Jupiter and Saturn are in the same spot in the sky. It won't be the original spot, but it'll be, again, viewed aligned from the Sun. The diagrams will do a better job than I am of showing this, explaining this. And then I'm going to talk a little bit about why it's not the same period of time between two conjunctions always, because the Earth is moving. We're on a moving platform, and that affects the length of time between two successive conjunctions. So here's our start. I just arbitrarily said, let's place Jupiter and Saturn to the left of the Sun in this diagram, and I'm going to call that 0 degrees. That's going to be our reference line for angle, and I used a protractor in future slides to hopefully semi-close position Jupiter and Saturn on their orbits. And I'm going to call this 0 years starting alignment. So now our task is to find out, as these planets move around, and I'm taking a view above the solar system and we're watching the planets move this way. Of course, Jupiter is going to complete one orbit before Saturn completes one orbit. So roughly, 12 years for Jupiter, 30 years for Saturn, the very rough numbers. But Jupiter is going to take less time to come back to this starting line, back to 0 degrees. So let's see what happens step by step here. I just arbitrarily chose half of Jupiter's orbit time, 5.93 years, and positioned the planets after 5.93 years have elapsed since the start. So Jupiter is here, halfway around its orbit. It started here, it's halfway around. How far has Saturn moved? Well, I calculated the angle that Saturn has moved, 5.93 years, divided by 29.46 years, the period for Saturn's orbit, and then multiplied by 360. If the time would have been 29.46 years, divided by 29.46 years, we would have obviously had 360 degrees. Saturn would have completed one orbit. But I'm choosing a time here. This is my choice, 5.93 years. Jupiter is here. I'm going to calculate how far has Saturn moved around its orbit. And this is the fraction of its period that it's moved, 5.93 divided by 29.46. I multiply that fraction by 360 degrees, a full circle, and I find Saturn is at 72.5 degrees from the start. So it's moved along to here. Well, that position is roughly right. If I would be down at this location, that would be 90 degrees, a right angle. So here we are in a starting diagram, and Jupiter is out ahead, and our task is going to try to be determined, when does Jupiter come around here? Saturn's going to keep on moving, and we again have an alignment, the two being on a straight line that comes out from the Sun. So let's go a little farther. Let's let Jupiter make one full orbit. So I'm setting the time now at 11.86 years, the orbital period for Jupiter. And then in the same way, I've now calculated where Saturn is located. 11.86 years is how much time has elapsed, divided by the period for Saturn's orbit, 29.46. This gives us the fraction of the orbit that Saturn has moved through, times 360, 145 degrees. So here's Saturn. So we've not had an alignment. Jupiter's been out in front this whole time, but I hope you're starting to see Jupiter is going to be catching up with Saturn on the sky. Saturn's going to keep on moving. Jupiter is going to move faster in angle and catch up with Saturn. And just to kind of roughly confirm this 11.86, half of Saturn's orbital period is 14.73 years. That would be at this position, where Saturn has moved half of its orbit. We're at 11.86, so this is a reasonable location, less than 14.73 years. Okay, let's go a little further here. Now I'm letting Jupiter complete 2 full orbits. Jupiter is back to this starting line for the second time. It went around once, 11.86 years, and now I'm letting the time go another 11.86 years. So we're at 23.72 years. Jupiter has made 2 orbits, but Jupiter has moved past Saturn on the sky. If we're observing from the sun, there'll be a time someplace back here where Jupiter is here and Saturn is out here. I've calculated the angle to plot Saturn on its orbit. Again, the time that I've selected, 23.72 years, divided by Saturn's orbital period, multiplied by 360, 290 degrees. 270 would be right here. Angle up to this spot in the orbit. So there we are, and we've gone too far. 23.72 years is too long of a time. There's been an alignment prior to 23.72 years. Now we're going to get into some calculations. They're not difficult, so hang in there. So for alignment, my problem is to find the time after 0 years, find the time at which the angle to Jupiter, around its orbit, equals the angle to Saturn around its orbit, both of those angles being measured from the 0 degree line. Well, for Saturn, that time divided by its orbital period times 360, that'll be the number of degrees that Saturn has moved around its orbit. For Jupiter, there's a little slight complication. This time is larger than 11.86 years. It's larger than 1 orbit for Jupiter. Jupiter is on its second orbit. We saw that in the diagrams. You might want to stop and back up the video to play that again. But Jupiter is on its second orbit. So to calculate an angle in between 0 degrees and 360 degrees, I'm going to subtract 11.86 from the years. So that's why it's not just t here. For Jupiter, the time from the start line is this t unknown minus 1 orbital period for Jupiter. So this will be the number of years that have elapsed for Jupiter's motion after 1 orbit was completed for Jupiter up to this alignment time. So I hope you're following that verbal argument here, that verbal discussion. It does work, and I'll be double checking it later. You'll see that it does work. So we have the angle for Jupiter then in degrees. Divide by the period of Jupiter. I divided by the period of Saturn up here. Just for clarity on the mathematical operations, I chose to put the multiply by 360 before the division. So we're going to set these 2 angles equal to each other. That's what we want. We want alignment. We want the 2 planets in position where they're the same number of degrees away from the starting line, away from the 0 degree line. So here's the angle for Saturn. Notice that 360 would appear on both sides of this equation, so it cancels. I'm not bothering to copy that down. I'm not bothering to work with that number, 360. That just makes the numbers bigger and harder to use. So there's a times 360 on the left, there's a times 360 on the right. Those can be canceled. So I have t divided by 29.46 equals the quantity t minus 11.86 divided by 11.86. We're going to cross multiply here. Multiply both sides by 11.86. I'm going to multiply here on the left. I'm going to multiply here, which will cause a cancellation of this denominator. And I'm going to multiply both sides by 29.46. When I multiply by 29.46 on the left, it cancels this division, or they equate to 1, to a factor of 1. And here I have to multiply 29.46 by both t and the minus 11.86. I have to distribute 29.46 through the parentheses, and I get these two terms on the right side. So 11.86t equals 29.46t minus 349.4. I need to gather like quantities, the t's, and I want to move this number to the left side. So first I'm going to add 349.4 to both sides, so it appears here. And at the same time I'm going to subtract 11.86t from both the left and the right. When I subtract 11.86 from 29.46, hopefully I come up with 17.6. You might want to double check my work. And lastly, divide both sides by 17.6, and I find 19.85 years is t. 19.85 years is the length of time in this simple model, assuming circular orbits. It's the length of time between alignments of Jupiter and Saturn as seen from the Sun. So then we have a little drawing of that here. And what I did, I put in 19.85 years, and I calculated the angle for Saturn, where is it in its orbit, and I calculated the angle for Jupiter, being careful to remember that Jupiter is on its second orbit here, so I need to subtract off the time to complete one orbit. At 11.86 years, Jupiter would be here, and now we have this remaining number of years, 7.99, after we do the subtraction. This is Jupiter's motion for 7.99 years since it was at this 0 degree start line. And I end up with the same number. There's a rounding. I didn't keep all the digits I could have in doing this calculation, but they both give 242, roughly 0.5 degrees. And I've plotted those two here, and I've drawn in this line. We started at time equals 0 with Jupiter and Saturn aligned on this line. And now we find after 19.85 years, the two planets are aligned over here as viewed by somebody on the Sun. Well, if we were viewing from the Sun, if we lived on the Sun, the conjunctions, assuming the circular model, would happen every 19.85 years, but we live on the Earth. So when we're on the Earth is moving from around, the Earth moves around the Sun, but from looking at Jupiter, where it's sometimes where this green line ends or starts, and sometimes where this blue line starts. And if I would be over here at the start of this blue line and look out to Saturn, let's put Saturn back just a little bit. At a time less than 19.85 years, Saturn would be back here. Jupiter would also be back a little bit in its orbit. But I would have a conjunction. So the conjunctions can occur with less than 19.85 years. If the Earth was over here when we're starting to get this alignment, then a little bit longer than in its motion in its orbit, I put Saturn out here, greater than 19.85 years. Jupiter also is a little bit further along in its orbit if the time is greater than 19.85 years. But again, I would have an alignment. This is just one of the possibilities. I didn't do all the combinations of where this viewing could take place. Just thought it would be too complicated to put more lines in here, but hopefully this gives you some inkling, some understanding that the conjunctions can have less than 20 years, less than 19.85 years between times of conjunction. Sometimes it can be more. Depends on where the Earth is in its orbit. So there's a discussion. You might want to view this again and pause in the middle of it as you view. I hope you watch this conjunction December 21st, 2020. If you'd like some astronomy and physics information, there's a full year's coursework of lectures and sample problems worked out for physics at physics.gpclements.com. For the astronomy, it's mostly descriptive lectures of short lectures, 15 minutes or less, and a few sample problems. Astronomy.gpclements.com. Both these websites are very simple websites, not fancy at all. I do not use cookies on this website. I don't track any of your personal information. There's no donation requested, totally free. You do not give me your email address. You will not receive email from me. You can just go to this website and look at a list of titles of the YouTube videos I have. It's, I think, getting towards 500 physics and astronomy YouTube videos. Each video has a title, the length in minutes for the video, and a short description of what you would be viewing. Again, hope you view the December 21st, 2020 conjunction for Jupiter and Saturn.